Hello, everyone. It's just that I needed the microphone, but I'm ready. So I'm going to share the screen. Could you confirm, Chilin, if you can see the screen?
Yes, it's very clear. Thank you.
Okay, so Salamat Pagi and good morning. Good morning, everyone. Well, I'm very happy, very excited to be with you today. It has been a very long time since I went last time to Malaysia and Singapore. I have very good memories from these road shows. I met wonderful people in Elken. I also visited gorgeous places. So it's always a pleasure for me to create these kind of trainings. And hopefully we will do one physically very soon. So thank you so much for attending to the training. And well, our topic today is very interesting. We are going to speak about immunology and KIngton, of course. Immunology, as you may know, is very important because we consider that it is the key in health and disease. When we speak about the immune system, we are speaking about the real key of health and disease. But before we start, I would like to give some, let's say, or I would like you to remember a few things about KIngton, because this is a very common question, a very current question you can receive when you are introducing someone to KIngton for the very first time. People can ask you, what is KIngton? And what most of these people, I'm pretty sure, what most of these people think KIngton is, when you are introducing them to KIngton for the very first time, is that you are speaking about fresh water and salt. So this simple mixture of fresh water, mineral water, and sodium chloride. But what you may explain to these people is that KIngton is much more than that. KIngton is a very complex substance that consists of a mixture of major elements or major minerals like chloride, sodium, magnesium, calcium, potassium, etc. Minor and trace elements like zinc, copper, molybdenum, vanadium, manganese, etc. But also, apart from minerals, we can say that in KIngton we have also proteins, amino acids, lipids, carbohydrates, and even vitamins. So I think this is important to know and always to remember. In fact, for example, let me show you this chemical analysis we realized in 2016 at the University of Alicante in a department of analytical chemistry. We did several analyses, chemical analysis of our ampoules of KIngton Isotonic and KIngton Minerale. And what we were able to determine were at least 78 different natural chemical elements or minerals. But well, as I just said, in KIngton, in the KIngton ampoules, we have much more than minerals. We also have organic nutrients, proteins, amino acids, carbohydrates, etc. Most importantly, we were able to determine in 2019 and 2020 several water-soluble vitamins and fat-soluble vitamins, like, for example, D-biotin, riboflavin, cyanocobalamin, that is vitamin B12, etc. And vitamin K2, that is a fat-soluble vitamin. So just to summarize what we just said, the next time someone will ask you, what are the ampoules? What is the content of KIngton's ampoules, KIngton Isotonic or KIngton Minerale? You may answer that there are, for one side, minerals, so inorganic and, in this case, bioavailable micronutrients, major, minor, and trace elements that are naturally present in the substance. We have also macronutrients, carbohydrates, amino acids, proteins, fats, etc. Also vitamins, as we just saw. And of course, we have something that we don't know yet. We continue analyzing our substance, our KIngton, and we are discovering in 2019, 2020, we discovered some vitamins that are very important. But probably in the next few years, we will discover another or other kind of biomolecules that have special activities in health, and that probably allows us to recover from a disease. So this is the complexity of KIngton's chemical composition. Well, before we start speaking about immunology, I think it's very important to remember something about the anatomical, let's say, composition of the body. We have a basic unit of life, as you know, that are cells. Every animal that you can think about, every human being, of course, but every animal is or consists in cells. It's the basic unit of life. These cells can be organized and work together to conform tissues, the next level. Several tissues together can form organs, and different organs all together in a kind of collaboration conform the different organic systems, like, for example, the immune system or the digestive system or the urinary system, the respiratory system, etc. All the systems that conform an organism all together, as I just said, conform an organism, an entire and an independent organism. But the key here are cells. It's the basic unit of life. So when we are going to speak about immune system and immunology, we are going to speak about, sure, a few organs that are important from the point of view of the immunity. But the most important are cells. We are going to see different kinds of cells that conform the immune system, that are specialized and that they work together. And that are the ones that protect us against pathogens or against allergens, against any kind of external factor. Another thing that is important before we start speaking about the link between immunity and immunology and KIngton is to understand that there are 3 different levels of immunity in animals and in the human being, of course. Immunologists used to speak about these 3 different immune levels. We have, first of all, a physical barrier that is represented by the skin and the mucosas. We say physical barrier because it's continuum. It's some different tissues all together forming a continuum, some continuity, and that are a real physical barrier that avoid the entrance of external pathogens, external microorganisms, or even other proteins like allergens. But we said that it's a physical barrier, but also a chemical barrier, because in our mucosas and in our skin, we have also some molecules like lysozymes that are or that have a bactericidal activity, or that can have antiviral or antifungi activity. So let's say that our first level of immunity, it's just this physical and chemical barrier. But what happens when this physical and chemical barrier is broken? imagine a burn or imagine an injury, a big injury. This physical barrier is broken. So the pathogens, the microorganisms, can go within the body, can enter the body, and can cause infection. They can infect our tissues. But we have another two levels of immunity inside our body. It's not the skin, it's not the mucosa, it's inside our body, organized by some specific cells called leukocytes or white blood cells or immune cells, that they are going to conform the innate immune system and the adaptive immune system. We will see it in a few minutes. But what I want you to understand in this slide is that we have three different levels of immunity. First of all, the physical and chemical barrier. Second, an innate immune system, and an adaptive immune system. And in this innate and adaptive immune system that is inside, as I said, inside our body, our organism, it is composed by several different kind of cell types, immune cell types, that are specialized, but that they work together. For example, we have the eosinophils that are specialized in fighting against some worms, some, for example, intestinal parasites. It's specialty. But we have also neutrophils or lymphocytes that have another activities. Neutrophils, for example, what they do is they are the first immune cell that goes to an area that has been infected. They are very quick, they are efficient, and they are the first that goes to this infectious or infection site. So do you remember that I told you that we have an innate and an adaptive immune system? Let's see that. Let's focus on the difference between innate and adaptive immune system or immune response. We can see on the left the innate immune cells. Here in violet, we have all the innate immune cells. And what they do is that they have a very quick response. The innate immune response is very quick. They can act immediately once a pathogen goes inside or succeeds going inside or entering the body, the organism. The first cells that goes to the infection are neutrophils and are the other immune cells of the innate immune system. So they are very quick, its response is very quick, but they are non-specific. They can fight against viruses, fungi, bacteria, allergens, it doesn't matter. Tumors as well, it doesn't matter. They are non-specific. But they are less effective than the cells of the adaptive immune system. We will see it in a few seconds. They also don't develop immunological memory. So this means that vaccines target aren't these cells. Okay. So let's say that it's the body's second line of protection. And we also can say that the cells of the innate immune system are like the normal police. Imagine the New York City police. They are very quick because they are always patrolling the city. And if there's a murder or if someone stole something, they are going to act. They are non-specific. They are going to act no matter the nature of the criminal act. And but they are less effective. They are not very effective. They don't have hard training. They don't have the most developed weapons, and and these kind of things. It's just the normal police. But the adaptive immune system is like the SWAT. It's like the elite police. They are very late in their response, like the SWAT. The SWAT are normally isn't patrolling the city. This is the work of the normal police. But when things can go worst, it's the SWAT that enters and that starts doing its job. It's like the adaptive immune system. When the disease is very severe, when the infection hasn't been controlled by the innate immune system, it's the adaptive immune system that is going to start working. So its response is very late, but it's height specific and very effective. It's very effective like the SWAT. They have the best weapons, the hardest training, and we can say that they are the most efficient, the most effective cells of the immune system. But they work together. Innate immune system cells and adaptive immune system cells work all together. They are specialized, they have different reads, the difference in the effectiveness and the efficiency, but they work together. These adaptive immune system cells are lymphocytes, B cells, T cells or T lymphocytes, B lymphocytes, etc. And we used to say that there are the body's third line of protection. Now we are going to focus on neutrophils. Before I said that neutrophils are the first immune cells that goes to an area of infection. When a pathogen enters and succeeds going inside or crossing the first level of immunity, skin and mucosas, and goes inside the body, the first immune cell that goes and attacks this pathogen are neutrophils. They are, as you can see, cells from the innate immune system. So they are very quick, but non-specific and less effective than lymphocytes or adaptive immune system cells. So this is one of our latest research we developed at the University of Alicante with these neutrophils. Okay, this one, neutrophils. And in this video, I want to show you how a neutrophil used to work. We are seeing a neutrophil that is chasing a microorganism that in this case is a bacteria. It is following the bacteria, and after a few moments, it's going to succeed and it's going to phagocyte or to gobble. Now, it's going to gobble the bacteria, the pathogen. It can be a bacteria or it can be another kind of pathogen. But once the microorganism, the bacteria, the pathogen has been gobbled, has been phagocyted, the neutrophil that we can see on the left in this image, the neutrophil needs to eliminate it inside of himself or of itself. It's what we call the intracellular killing. Intracellular because it is inside the cell, the neutrophil, and killing because what it is going to do is to destroy this bacteria that has been chased and gobbled. You can see it here in this image. You can see in red, you have the bacteria. Remember the bacteria that has been followed and chased. This bacteria in red is going to be gobbled by the neutrophil. Now we can see the bacteria that is inside the neutrophil, inside the cell, intracellular. And now what's going to happen is that the neutrophil is going to use two different strategies to eliminate, to kill the bacteria that has been gobbled. You can see on the left one of the strategies, that is the simple use of some enzymes, some molecules that are toxic for the bacteria. So this one strategy, the neutrophil is going to use these enzymes, these hydrolytic enzymes to kill the bacteria. But there's a second process, both of them are important. Second process that we can see on the right in this image called respiratory burst. This respiratory burst consists in the use of reactive oxygen species like hydrogen peroxide or hydroxy radicals. There are free radicals used by the neutrophil to kill the pathogen, the bacteria in this case. It's what we call the respiratory burst, the use of reactive oxygen species to eliminate the bacteria, the pathogen that has been involved before. These two different strategies are essential. So what we discovered in 2019 and 2019 was that we were able to increase this process, respiratory burst, this process of respiratory burst in neutrophils that were growing surrounded by KIngton isotonic. So it's another proof of the potential immunomodulatory effect of KIngton ampoules. This research was developed in vitro conditions. It's an in vitro experiment, but it's very interesting because if we were able to increase this process of respiratory burst, it means that we could improve and increase the bactericidal activity of neutrophils. As I said, neutrophils needs to gobble the bacteria, the pathogens, but needs to kill them inside of itself or themselves in the process called intracellular killing. And one of the most important strategies is respiratory burst. If we were able to increase the respiratory burst, we were able to increase the bactericidal activity of neutrophils. That was a very, very interesting discovery. Well, this experiment that we presented in the 5th European Congress of Immunology in 2018 was developed with neutrophils from healthy donors. The next year, in 2019, we presented another experiment in a National Congress of Immunology here in Spain. And we showed how this effect of KIngton isotonic in human neutrophils was also present in not only in healthy donors neutrophils, but also in neutrophils from patients suffering from psoriatic arthritis, that is an autoimmune disease. And this was also very interesting because we never know if something works in healthy donors or in healthy population. Maybe it doesn't work in people suffering from a disease. So this was very important to know that this effect of KIngton isotonic in neutrophils was observed in healthy population, but also in people with autoimmune diseases. So apart from neutrophils, remember, the neutrophils, part of the innate immune system cells, we also developed years before in 2008, 2009, 2010, 2011. So before, in our first experiments, we worked with other immune cell types, the macrophages and the lymphocytes. Macrophages that are immune cells from the innate immune system, and T lymphocytes and B lymphocytes that are immune cells from the adaptive immune system. And what we did, let me show you that. What we did was to, we extracted blood from healthy donors, and we isolated these two different cell types, lymphocytes and monocytes, and we did cell culturing in 3 different cell culture medias. On the left, we have RPMI. In the middle, we have a conventional saline solution. And on the right, we have the cell culturing of these lymphocytes and monocytes in KIngton isotonic. You can see below this image, the major image, you can see the different cell culture medias. So RPMI is just this simple culture media, very used in the laboratories of molecular biology, bioengineering, etc. The substance that is in the middle is a conventional isotonic saline solution that is very used in hospitals. And on the left, we have the KIngton isotonic. So let's go little by little, because this experiment is a little bit hard to understand. So remember, lymphocytes and monocytes that were isolated from healthy donors in 3 different cell culture medias. And in these 3 different cell culture medias, we added, apart from the cell culture medias, we added some stimulants called methogens, that what they do is to increase the proliferation, the activation and the proliferation of immune cells. We can see them written in blue. We have PHA, PMA, etc. These are methogen or stimulants. We didn't add stimulants in where you can see control. Control means that we didn't add stimulants. We didn't add methogens. Okay, so let's see the first column on the left. So the lymphocytes and monocytes that were cultured in this cell culture media called RPMI with the methogens, with the stimulants. What we observe is the appearance of these kind of black, let's say black circles that are aggregates of immune cells, of lymphocytes and monocytes. These black circles we can see are lymphocytes and monocytes that have proliferated, they divided, and they increased their populations a lot. Millions, we are speaking of millions and millions of immune cells. This means the appearance of these aggregates means that RPMI, the cell culture media, was able to maintain alive lymphocytes and monocytes, and was able to activate and to generate the proliferation of these lymphocytes and monocytes. So the increase of the population. It's the same that happens in the body when there's a process of infection. There are millions of bacteria or of fungi, viruses. So the immune system needs to increase the quantity of immune cells. They need to multiply, to proliferate, because we are speaking, they need to fight against millions of bacteria or viruses or fungi. So what we are observing here in the lab, in vitro experiments, is that RPMI with stimulants is able to produce this increase of lymphocytes and monocytes. What can we see in these immune cells that have been growing in conventional saline solution? There's no appearance of these black circles we mentioned before. you cannot see them in these cell culture trials in a conventional saline solution. This means that the saline solution plus the methogens, the stimulants, isn't able to maintain lymphocytes and monocytes alive for significant period of time, and isn't able to generate the proliferation, isn't able to give all the nutrients these immune cells needs. This is a reason why we don't observe the appearance of these black circles, no, these aggregates of immune cells. And on the right column, we have these cell culturings of lymphocytes and monocytes, but in KIngton isotonic, or KIngton isotonic as a cell culture media. We are observing, with the addition of stimulants, PHA, PMA, etc., the appearance of these black aggregates. This means that in KIngton isotonic, we have enough nutrients and enough factors to maintain white blood cells or immune cells alive, and to allow them to proliferate and to be activated, etc. Well, this is interesting because here we are comparing. We don't have to compare RPMI and KIngton isotonic, because RPMI is just a cell culture media. But now what we have to do is to compare the conventional saline solution or artificial isotonic solution versus KIngton isotonic. The conventional saline solution is unable to maintain these immune cells alive, but KIngton isotonic does, and is able to generate these cell aggregates. But the most important discovery of this experiment was what we can see in this row, in this line. Control, remember, means that we didn't add methogens, we didn't add stimulants. What we only have in the three different columns, but in this row, in this line, are the cell culture medias. And the only cell culture media that was able to maintain these lymphocytes and monocytes alive and to generate these aggregates was the KIngton isotonic cell culture media. And this is the first time we were able to speak about an immunomodulatory activity of KIngton, because it seems that KIngton isotonic by itself was able to activate the cells and to generate this proliferation of lymphocytes and monocytes. That is a proof of its immunomodulatory activity. The following year, in 2010, we did some experiments trying to measure some immune markers like the interleukin-2, because we were trying to explain what we saw here. Why KIngton isotonic was able to activate lymphocytes and monocytes without stimulants by itself. It was very mysterious and very interesting to dedicate a research only for that. So we measure some molecules, some immune markers, like, as I said, the interleukin-2. We saw an increase of the expression of interleukin-2 in lymphocytes. The interleukin-2 is, as you know, it acts as a growth factor for T lymphocytes. This explains why the T lymphocytes proliferated in the KIngton isotonic cell culture media. It also induces all types of lymphocyte proliferation and subpopulations. It's what we saw in the 2009 experiment. It activates the proliferation of the lymphocytes, not only T lymphocytes. So it's just, it's a kind of natural human stimulant, but it's natural. Our body and our immune cells produce this interleukin-2. It's not an external stimulant. So we were able to increase that this interleukin-2, and well, some years later, in 2016, more or less, we did a special experiment with the regulatory T cells that are a subpopulation of T lymphocytes that, let's say that they are the one that leads the entire immune response. Regulatory T cells, or Treg cells, regulate or suppress the activity of other immune cells. And they are very important, for example, to control autoimmune or to prevent autoimmune diseases, because they are the one that are saying to the neutrophils, for example, or to other lymphocytes, they are saying, no, we need to act in infection processes, not against our own tissues. So they are a kind of this is why we call them regulatory T cells. They are the one that really leads the entire immune response. And what we saw in vitro experiments as well, what was that we were able to increase the percentage of this subpopulation of Treg cells. And this was very interesting in a context of preventing or managing some autoimmune diseases, but also in when we are trying to manage some infections, it could help managing the entire immune response to be more efficient. So to summarize what we just explained, we have been developing research in immunology in innate and adaptive immune system cells, lymphocytes, monocytes, neutrophils, also some mother cells. And well, this is the discoveries we did in the University of Alicante, from my point of view, can be related to the presence of some specific trace elements in KIngton ampoules, the vitamins, other biomolecules we are trying to determine in our substance. But it's with no doubts, we can say that it is due to this complexity of the chemical composition that we are able to modulate some immune activities. Well, this is something that we just saw at the beginning of the presentation. We were able to determine at least 78 different bioavailable natural chemical elements, minerals, most of them, and also some biomolecules. Our experience in research and in hospital and clinical or medical, let's say medical evidence is very hard. We have many documents, thousands of clinical cases, more than 120 years of experience in hospitals and in other clinical or medical centers, and more and more scientific research has been developed these few last years, and all this information allows us to say that the therapy with KIngton Isotonic and KIngton Minerali is very effective. Another thing we didn't mention at the beginning is that, and this is very important, well, this complexity of KIngton ampoules is always present in our internal liquids. the extracellular fluid, what we call the internal medium. You can see it in this image. Isotonic seawater, isotonic, KIngton isotonic, and the external fluids, not the intercellular, but the extracellular fluids, have a very similar composition. So this may be another reason why it is able to produce this kind of effects in the immune cells and other type of cells. Of course, another key factor of KIngton is that it's a 100% natural product. We don't heat the product. We don't use radiation. We don't use processes that can, for example, electrodialysis or any process that can alter the natural composition of seawater, and the natural composition of KIngton is avoided completely. So what we use is a double cold microfiltration. Before we finish, let's see this slide that can help us to understand the different uses of KIngton ampoules. We have KIngton isotonic that can be used in some specific immunological disorders, not of course as a main treatment, but it can help us to increase the efficiency of the major treatment. It can give us the trace elements, the major elements, the other nutrients our body and our immune cells need to manage these immunological disorders. These phenomena we observe with Treg cells also allows us to say that it could be interesting in some specific immunological disorders like psoriatic arthritis or any kind of arthritis. Of course, infectious diseases, because the immune system, as I said at the very beginning of the presentation, is the key in health and disease. So we can help us controlling or managing infectious diseases or preventing them, digestive disorders, and dermatological disorders. In the case of KIngton Minerale, the difference is the difference of salinity. There are more minerals in KIngton Minerale. It's a salinity of 3.3, and the salinity of KIngton isotonic is 0.9. So KIngton Minerale, we are going to use it in several metabolic diseases, also metabolic syndrome, of course. Metabolic diseases like type 2 diabetes or type 1 diabetes. Of course, electrolyte disorders, because of the content of electrolytes in KIngton Minerale ampoules. Maintenance of bones and muscles, teeth in good conditions because of the content of magnesium and other important calcium and other important minerals. And most importantly, the lack of energy, the chronic fatigue, psychological the maintenance of correct psychological function, etc. Of course, because of the content of some enzyme cofactors that are important in metabolic processes and that are essential in the synthesis of ATP, of energy. So thank you very much for attending to this quick training. I hope you are going to find some interesting tools when you are going to introduce people to KIngton products and KIngton and its link with immunology. And okay. I need to find the thing now. Okay, now. There are some questions.
Yeah, but before that,